Hello everybody, welcome my dear students. Let's begin this type of problems. Prove algebraically that the sum of any two consecutive integers is always an odd number. Let's to start with two consecutive integers. Okay. What about two consecutive integers? Like the first is n and the consecutive integer n plus 1. Is it right? Of course. What about the sum of any two consecutive integers? So you must add these two numbers. Continue. N plus n equal 2n plus 1. Look at the required is always an odd number. What's the meaning of odd number? Odd number is 2n an odd number? No. 2 which is mean double or twice. Twice a number or double a number, of course an even, but when you add 1 to the even, the answer will be odd. Of course the answer will be an odd number. Let's see another one. Prove algebraically that the sum of any three consecutive even numbers. What about consecutive even number? Look, the first even number you should say 2n, the first even. Then the second even consecutive to this number is 2n plus 2. Yes, you add 2. The third consecutive 2n plus 4. You add 2 on the last number, become 4. What about the sum of the three consecutive numbers? Then let's begin to add or do the summation. 2n plus 2n plus 2n equal 6n equal 6n, but 2 plus 4 another 6. What about the required? The required is always a multiple of 6. What about multiple of 6? As you see there, 6 and 6. What about taking 6 as a common factor from this term equal n, and 6 common factor from this term equal 1? So this is a multiplication times 6, so it's a multiple of 6. If there is here 5, it's a multiple of 5. 4, it's a multiple of 4. 3, it's a multiple of 3. 6, it's a multiple of 6. Let's see another question. Prove that 3n plus 1 squared minus 3n minus 1 squared is always a multiple of 12 for all positive integers values of n. Let's begin to work out this expression and we decompose the square. It's called complete square. It's called a complete square. How we can decompose? Rewrite this expression, please, and we will start together. The first wheel squared, the second wheel squared, first times second times 2, first times second times 2, 6, don't forget, n, minus, open bracket, please take attention, the bracket is important. The first wheel squared, the second wheel squared, the first wheel squared, the second wheel squared, the first times second times 2. This sign is always right here. This sign, please conserve this sign. The first times second times 2, 6, n, don't forget. So this negative will change the sign of any term inside the bracket. This negative sign will change all signs inside the bracket. So the expression don't change, but change please, it will be negative, change please, it will be negative, change please, it will be positive. Look carefully, this term and this term, you may say it's like terms, but opposite sign. Like terms but opposite sign. 0, 1, minus 1, 0, 6n plus 6n equal 12n, because we add or subtract, which is called like terms. This answer, look at a multiple of 12. Any term has 12, this is a multiplication. This is a multiplication. So n is multiplied 12. So this term is a multiple of 12. This term is a multiple of 12. Let's see another question. N is an integer. Prove algebraically that the sum of the expression n times n plus 1 and n plus 1 is always a square number. Let's start with the expressions that we will make summation. Rewrite please. N times n plus 1 plus n plus 1. Please decompose. You will multiply n, you will multiply it by all the values all the values in the bracket. N times n squared, n times 1 equal n. Don't forget plus n. Don't forget plus 1. These are called like terms. N squared plus 2n plus 1. This expression, my dear students, please think to factorize, since I play this mathematics subject, I should think to factorize any expression. Think to factorize any expression, my dear students. N plus 1 times n plus 1. So it's almost the same, equal n plus 1, which is repeated 2 times, called square number, repeated 2 times, because n plus 1 is repeated. Repeated twice. Let's see the last example. Prove that the expression 2n plus 2 squared minus 2n minus 3 squared is always a multiple of 12. Don't worry about a multiple of 12 for all positive integer values of n. Let's begin to work out. Please rewrite 2n plus 3 squared minus 2n minus 3 squared. Let's begin to decompose this square. It's called complete square. The first will be squared. Attention please. The second will be squared. The first term times the second term times 2 equal 12. Don't forget n in this term, minus open bracket please. You should open bracket because the negative sign will change all the sign inside the bracket. The negative sign will change. All the signs inside the bracket. But let's do another complete square. The first term will squared. The second term will squared. The first times second times 2. The first times second times 2. Don't forget the n in this term. The negative sign will change. Please rewrite. Carefully. The negative will change the first term. It will be negative 4. The second term, it will be negative 9. The third term, it will be positive n. Look carefully. This term is n. It's called additive inverse. The sum equals 0, and the positive 9 and negative 9 additive inverse sum equals 0. But this term is like terms. The expression will be 24n, and 24n is a twice of 12 n, or you may say 12 times of 2n. This that explain a multiple of 12 for all positive integer values. 12, which means a multiple of 12. Thank you, my dear students.